So hello everyone, welcome back to the channel again. So today I've come up with the part 2 for the same problem solving of logarithms, JEE Mains and Advanced. Look at the first problem of JEE Mains, which is probably very easy. So we need the logarithm of this to the base this. So what we can see is that is just 2 root 2 to the power x should be 32 into 4 to the power 1 by 5, right? This is how we need to express it. Now let us take, we can write this as log 32 into 4 to the power 1 by 5 to the base 2 root 2 should be x, and we need to find this x, right? So log, now we need to completely turn it into the terms of 2 so that they become, like, we can see 2 is the common in both of them. So 32 can be written as 2 to the power 5 and 4 can be written as 2 to the power 2 into 1 by 5, because 1 by 5 we already have that. Alright, and root 2 can be written as 2 to the power 1 by 2, right? So log 2 to the power 5 plus 2 by 5 to the power 2 1 plus 1 by 2 is x. Now log 2 to the power 27 by 5 to the base 2 power 3 by 2 is x. Now using the property again, log b to the power base n power k is log b to the power n, b to the base n divided by k. So using this theorem we can write log 2 2 to the power 27 by 5 to the base 2 into 2 by 3 is x. Now we can take this term and bring it here, right? So 27 by 5 into 2 by 3 into log 2 base 2 is x. So 3 times 9 is 27. So 18 by 5, and this is just 1. So 18 by 5 is x, or we can write x as 3.6. That's how we found the value of x in this question. So this the problem's solution is 3.6. Now let's look at the next problem. Now this is the second question. So we have a long series which we can see. Now to solve this, we will use the base changing theorem throughout the question. So we can write this as log 4 by log 3, this thing, the single thing, multiplied by log 5 by log 4 multiplied by log 6 by log 5 multiplied by log 7 by log 6, and so on. It just goes on like this into log 9 by log 8. 3 doesn't cancel out, sorry. Yeah, that is the one which will remain. Log 3 remains. Log 4 cancels out, log 5 cancels out, log 6, log 7, log 8. What is left is log 9 by log 3, and that can be simply written as log 9 base 3, and that is just 2. So the value is 2. Wasn't so very quickly, right? It was just hardly a 15 seconds question, and that was very easy. Let's proceed to the next question. Now this is the next problem, and we'll use some basic identity in this to solve it. Now we are given the expression that a square plus 4b square is 12ab. Now to bring it in the form of a plus 2b, we can write it as a plus 2b whole square minus what we say is 4ab. alright, is 12ab. So a plus 2b whole square is 16ab, which becomes a plus 2b is root 16ab, which is 4 root ab. Alright, so now we'll just take this value and put it in this. So log of 4 root ab. Alright, and ab to the power 1 by 2. So proceeding further, we can write this as log 4 plus log root ab, which is log 4 plus log ab by 2, and this simply becomes log 4 plus log a by 2 plus log b by 2. And that's how the option may look like when come in the company exam. Otherwise it can't be simplified further. This is the final expression which we get. So this is how we derive the value of log a plus 2b. Let's look at the next question. Now this question is again the same as the part 1's first question, I guess. So here we are again given a GP, right, which is 0.1 plus 0.01 plus goes on till infinity. Now here, let's find. Now I told you that sum in GP till infinity is a by 1 minus r, where a is the first term and r is the ratio of second by first term. So here we can get r as 0.01 by 0.1, alright, and that is simply 10 by 100, which is 1 by 10, or same 0.1. So sum of this series will be 0.1 by 1 minus 0.1, which is 0.1 by 0.9, and that is 1 by 9. So sum is 1 by 9. Let's go further. So the value of 0.05 log 1 by 9 base root 20, because we find this the value of the series. Now 0.05 can be written as 5 by 100, which is 1 by 20, and log root 1 by 9 base root 20 can be written as 20 to the power 1 by 2. So, yeah, now you might have gotten the click of this question what it wants. So log 9 to the power minus 1 to the base 20 power 1 by 2. Now 1 by 20 can be written as 20 to the power minus 1, and that is to the power log 9 minus 1 base 20 to the power 1 by 2. Now we can bring this minus 1 here, and minus 1 into minus 1 is 1. So 20 to the power log 9 base 20 into 2. Now using that theorem which we are using repeatedly in all the questions, mostly all the questions, log b to the base n to the power k is log b to the base n by k. So that's how we divided half and got 2 log 9 base 20. Now 20 to the power log 9 square to the base 20, and now we we know that 8 to the power log b base a is always b. So in this case our answer is 9 square, which is 81. So 81 is the correct answer for this, right? So I hope you understood this question since it was very easy to solve. It just required some basic concepts of GP, infinity terms, and some normal laws which we are using continuously in all the questions, right? Let's look at the next problem. So let's look at this question. So this says that if ABC are distinct positive numbers, then each different from 1, such that this whole expression you can read is equals to 0, then we need to find the product of these distinct positive numbers, that is a, b, and c. So what we'll do is we can see that these have same logs, like log a and log a, just the bases are different. So in this case, we'll use the base changing theorem to simplify our question. Now we can write this as log a by log b into log a by log c minus log a base a is just 1 minus 1 plus log b by log a into log b by log c, again 1 log b base b is 1 plus log c by log a multiplied by log c by log b minus 1 is equals to 0. Now what we'll do is we'll just add these three numbers, minus 1, so that's minus 3, and let's take minus 3 on the right side. So we get log a whole square by log b into log c plus log b whole square by log a into log c plus log c whole square by log a into log b is equals to 3. Now we'll make the denominator same to add all the numerators. So we get the expression as log a whole cube plus log b whole cube plus log c whole cube by log a into log b into log c, which is equals to 3. Now we'll take this on the right side. So log a cube plus log b cube plus log c cube is 3 into log a into log b into log c. Now, if you can see this expression, we are getting an identity that if a cube plus b cube plus c cube is 3abc, then a cube plus b cube plus c cube is 0. Yes, so we can simply put this, sorry, a plus b, yeah, just a minute. So we get an identity that a plus b plus c will be 0. Alright, I hope you all know this identity. So using this, we'll just use this identity in this equation, right? So from this identity, what we can write is log a plus log b plus log c is equals to 0. Now, since the bases are same in these three logs, we can write log a into b into c is 0. So log a b c is, now what we can write 0 is as log 1, alright, because anything raised to the power 0 is always be 1. So from this we get abc as 1, right? And in this question we need to find abc, which we have found that it will be 1. That's how we solve this question. Let's look at the next problem of JEE. Now this is the next question, which is again a little bit related to AP, arithmetic progression. So let's look at this question. If a, b, c are consecutive positive integers and log of 1 plus ac is 2k, then the value of k is. So for this, let's start with the question. Now for our ABCs, let's take it as a is, wait, we can take a as p minus 1, b as p, I'm not taking a since it will be confused, and c as p plus 1, right? These are all consecutive positive integers, and the case is that P is always greater than belongs to, say, natural numbers, right? That's the condition here. Now, for this, let's put this AC in this expression of log 1 plus AC. Now we are given that log of 1 plus AC is what? 2k. Now log of 1 plus p minus 1 into p plus 1 is equal to 2k. Now it's the identity of a minus b and a plus b. So it will be log 1 plus p square minus 1, right? Which is equals to 2k. Then log of p square is 2k. Alright. Now what we need to find is then the value of k is. So now we'll take log p square by 2 is k. So what k will be is log root p square, because this is a half and we took this half here. So k is log p. And what is p? P is b. So k is log b. And here the option B is correct. That is log b. Now let's look at the next problem of this question set. So now this is the last problem for today's video. Let's end this video with a very easy problem, which is one of the JEE Mains question. So in this, we have the question as that log x base 3 plus log y base 3 is 2 plus log 2 base 3. Now here we can write log xy base 3 using the law of logs is equals to, now 2 can be written as log 9 base 3. We are doing this to simplify this log 2 base 3. So log xy base 3 is log 18 base 3. So xy is 18. Alright. And what else do we have as information? That log x plus y base 3 is 2. Then we need to find the value of x and y. Now log x plus y base 3 is log 9 base 3. So x plus y has to be 9. Now we take one of the values, suppose x or y, whatever you want. I'm taking x as 18 by y. Now I'll put 18 by y here. 18 by y plus y is 9. Now this became a quadratic equation. Now we can simply solve it and we get our answer. So by solving it, our answer comes out to be, let's see, so y times y minus 6 minus 3, y minus 6. So y is either 3 or y is either 6. So y is either 3, y either 6. So let's see what values do we get for y if we put in this equation. So if y is 3, then x is 6. Only and only if y is 3, x is 6. And if y is 6, then x is 3. Alright, so let's see which is the most appropriate answer. So if y is 6, x is 3. If y is 3, x is not 9. So D option eliminated. C option is the most appropriate and the correct answer. So in this problem, our correct answer is option C, x is 3 and y is 6. So that's how we solve all the problems in today's video of JEE problem sets. I hope you found the video very interesting and understood all the questions very easily. And if you like this video, please comment, share, like, and subscribe our channel. And for any queries, you can always mail me on the mail ID given in the description. Thank you so much for watching. Bye.